Hello, live go. Hey folks, I hope I'm audible. Yes, I am.
Hello.
Yep. So it's weekend already, and we are again back with the session. So we have Sayam with us. So Sayam is a GSOC scholar, GSOC 2020, and he is a research engineer with Phaidra.ai. Phaidra is kind of a US based startup where they are creating some really cool stuff. So what he does is he trains some machine learning models and he does AI research to cool industrial automation stuff, right? So they are doing industrial automation like they are they are into cooling system like the flow rate of water and stuff that has to cool the production machineries. So Sam can probably explain better. I'm just a noob in AI. So we'll be having a casual talk like how you can get started with artificial intelligence and machine learning as a career and how you can pursue it, right? So Sayam is currently in his final year. We can say he's in final year, but he's also working as a full-time engineer with Phaidra.ai. So he's the most wonderful guy that I've ever met, right? So over to Sayam for the session. Yep.
Okay. Can you all hear me?
Yep, you
I'm
are
not.
audible.
I'm working on the two screens and I'm kind of confused right now which screen to look at first. So give me about a few seconds so that
Yep.
I set things up. Okay, where is that? Um, how can I share screen? So on the other screen, I'm also seeing the comment section. So if at all you want to share, if you want to ask something at any time, either interrupt me or just add a comment over there.
Yep.
Uh, Share screen. All right. Can you see this? Oof.
So
Now,
yep. We,
can you see the? Yeah, I can see the slide as well.
yep.
Okay, let me go full screen. Okay, how do we do that? Present slideshow.
Yep.
Is this? I do see some fancy stickers over here. Oh yeah, they are gone. Nice.
Yep.
So shall we begin or do we need to wait for some time?
Yep. We can start, I guess. Yep.
Yeah, all
This
right.
will be
So
fun.
yeah, so all right. Hello everyone. I am Sayam Kumar. As Anubhav also mentioned, I am a finally undergraduate at Triple IT City. Also, I did my GSOC in 2020 with NumFocus organization. So I kind of grabbed some sort of machine learning and Bayesian stats experience in that year, and then after that I went on to work as an AI research engineer with Phaidra, where we create AI powered control systems for any and all industries that may require. So if you have any complex industrial mill that may need some that may require some optimization room, we create that those sort of AI that can control the manufacturing mill. So more on that later. So the talk for today will be about introduction to machine learning, as Anubhav also mentioned. But more to it will be introduction to machine learning with memes. So I hope you all are excited to dive into it. So let's begin. So the agenda for today will be we'll be having fun. I'll be showing you a whole lot of memes, and through the memes, I hope that you'll be able to learn some good stuff. That's the entire idea. Uh, Obviously, the first question that you may ask is, "Hey Sayam, why are you showing us memes?" It's the weekend first, so to answer this question, I'm gonna answer show you a meme. So it'll be everything in terms of memes from this time onwards. So how I'm going to introduce machine learning would be so there are many ways or many different good resources out there on the internet. The good thing is there are many different resources on the internet. The bad thing is there are many resources, and it may take some time to find a good resource that can help you out or even get you started with machine learning. So the best would be the memes and have fun and then enjoy the learning. All right. Moving forward, the very basic question and the first question is what exactly is machine learning, and why is it kind of so much pop- popular these days? Uh, so first, let's get to the very basics, or kind of in crude terms, how we can define this machine learning. Uh, I know you were expecting some sort of meme, but first we need to get the basics right. Then I'm going to show you the good stuff. All right, so hang on with me. So what exactly is machine learning is that so these days it's the kind of uh, time that you will see a whole lot of data, or there's a whole lot of data out there on the internet that is, number one, much more in abundance, and it's growing too fast. So how you can make much more use of the data is that you can find some sort of patterns in the data, or you can use the data to predict some good stuff. So the idea of machine learning is that instead of we hard coding things out there in the PC, we let some sort of algorithm to find out how exactly we can make the best use of the data, either to predict a good stuff, or what we can also do is to recognize some sort of patterns in the data. So the broad idea is, instead of we explicitly writing out code, we let the algorithms out there to find out the logic themselves, and then improve themselves as soon as they get more data. So that's the kind of very crude definition of what machine learning is. And those guys who like Simpsons, uh, machine learning is about finding the pattern in the data. That's kind of one thing. Uh, Moving forward, I do hope you kind of like these sort of little bombs of memes. Uh, Carrying forward, what exactly is machine learning? So there are some sort of algorithms out there that can help you find some interesting patterns in the data, or can help you predict something meaningful if you have a particular target that you aim for. Uh, just to give you an example, it's a very trivial example that you'll also find in many starter machine learning books. Is that so? The problem statement is defined by given uh, the area of the land where you want to buy a house in, you want to have to predict what would be the price of the house. So alongside the information given is that what area does the land belong to, and what all good luxuries the area provide. So given all these sort of related information, this data set is by the way named the Boston housing data set. So given this sort of data set, can you do something meaningful with the data to predict what the price of the house would be in that area? So we do have some sort of algorithm that can
Hey,
help you do that. But
I'm sorry to interrupt you. So all we can see is that elephant meme. So
yeah, just to help the idea out better, machine
yeah.
learning, there are algorithms out there, and the algorithms cannot run without math. You just mix the two, and you do not create a penguin with the head of an elephant, but it's just that machine learning helps you create meaningful stuff instead of instead of creating stupid stuff like that. So uh, whenever you hear the term machine learning, it's not that the crazy trend or hype over there. Mathematics will directly come into play. So it's like whenever you are about to study machine learning, or about to explain a particular area of machine learning, mathematics will be uh, definitely involved in that. So the meme rightly explains that. Uh, so just a quick question: how many of know you? How many of you know this? The professor over here? Yeah, machine learning is cool, exactly. So what the meme says is that so the guy over here is Andrew Ng. He's a professor at Stanford. uh, he also created the deep learning course at Coursera, from which I also started my machine learning journey. So during his slides, I explicitly remember he says whenever something complex is brought into the slides, he always said, "Don't worry about it if you don't understand." And the way he explains about the various algorithms out there, at the end of the day, does explains a whole lot of sense. But he does calms the people down, because these algorithms can be very kind of difficult to understand if you are trying to understand them first. So don't worry if you don't understand. By the end of the day, if you revisit them again, you will be able to understand. So that's the good stuff. Yeah, classes भी इतने interesting नहीं होते. Yeah, I like that idea. So going a little more into it, by maths, I mean, so this slide I explicitly put up because it explains what exact maths is involved when you are going to explore a particular area of machine learning. So you can also see linear algebra out there, stats, some sort of probability theory will also be involved over there. So whenever someone hears the term, hey, machine learning, what I also did was, hey, let's ignore these things first. Let's first dive straight into what all the algorithms out there which people are using. And the time I started realizing, hey, these if I want to properly understand these machine learning algorithms out there, I need to have a good understanding of what linear algebra is, how statistics is getting used over there. And there is one algorithm in machine learning called naive Bayes, and that makes very good use of probability theory out there. So in order to make a, in order to get a really good intuition and good feel of what ML algorithms are doing, you need to have a good basic understanding, or you need to have a good basic understanding of what are tools it may require to exactly build that algorithm. Yeah, so I know what all vibes you all like. So at first, if you start, so by seeing these slides, you'll be all motivated. Hey, we need to get all the basic tools right, but it'll be daunting if you start all the things at first. So don't worry if you don't understand. Just try to revisit things later, and then uh, just try to revisit things again and again, and then hopefully it brings good intuition how ML algorithms work. So yeah, Coursera. So Coursera is the initiative, which was who's one of the founders was Andrew Ng. And then there's a course on Coursera named Deep Learning Specialization and the Basics of Machine Learning, which Andrew Ng uh, is a faculty over there, and he does a good job of explaining a whole lot of good stuff. So I do recommend check that course out. All right. I hope you may have got a good understanding of what exactly is machine learning and what it can do. Finding the pattern in the data is, yeah. All right. If I find anything difficult to speak in English, I'll definitely switch to Hindi. Uh, all right. So, what can ML do for us? So, can you create a bot? It can do almost everything on the internet, but the majority of things it is failing right now is clicking on that button where it says, "Hey, I'm not a robot." And I do hope you may also have seen this on a few different websites, and they are making it a lot difficult these days, because they need to actually make sure the person who is entering the website is human, not a robot. So it can literally do a whole lot of things these days. And of course, machine learning can make memes too. Uh, just see just these are just all good. All right. Yeah, all right. So I'm gonna just ask Anubhav over here, and if it will be all good if I switch to Hindi.
Yep, it would be good. Like, right, you can balance between the two. Yep.
Yeah, all right. Uh, Now we can ask the question. Hey, what? So whenever you see these terms, machine learning, both the terms machine learning and AI comes hand in hand. One thing you will be wondering about is what's the difference between the two. Uh, if you see any problem out there, one of the first things that you want to tackle the problem with is through stats. And by stats, I mean you may do some sort of data exploratory stuff and find out what exactly the distributions of the data lie into. And just to explain things a little more better, machine learning would come into play if you want to make much more meaningful sense out of the data, find out the patterns and make predictions out of that. And artificial intelligence is it looks good when you're presenting your algorithm to a whole lot of people, and instead of naming your algorithm as machine learning, you name that algorithm as artificial intelligence. So you wanna I'm not saying you're gonna follow what I just said, but broadly, artificial intelligence is a kind of superset of machine learning, and this involves trying to mimic the human intelligence power with the help of machines. So, artificial intelligence is exactly that, trying to mimic the human behavior and the human intelligence, artificially feeding the computers to do good stuff. Machine learning comes into play when you have a whole lot of data and you want to make meaningful use of that data. So that's the kind of difference. Uh, Now we're gonna move into what is deep learning. Yeah, this exactly the deep learning, right? When you hear your faculty out there, hey, we're gonna start some courses in deep learning, they're gonna put you deep inside the water and let you learn the stuff. Uh, but no. Uh, So, as I just explained a few moments back, artificial intelligence is a kind of a broad superset of techniques out there that's going to help you mimic human behavior. Machine learning out there is a kind of small set inside the artificial intelligence that helps the machine improve with experience, improve with data. The deep learning is instead of we putting out or we feeding in information in machine learning algorithms, like so just to give you an example, with a problem statement in mind, I'll give you an image. You're going to have to find out what animal is in that image. So the problem statement is, I'll give you an image, you're going to have to find out, or I ask the computer to find out what animal is in that image. What machine learning will do, it's going to aim for finding out what eyes are, what nose are, and where are the ears, and it's going to try to first find out the small features and then build on top of that features to find what the pet is. What deep learning will do, it's going to and what deep learning will do, it's going to take away all the feature extraction layers, and it's a way of learning things end to end. You're going to give an image, and then at the end of the model out there what you are trying to build, you will get just a name of what exactly is the pet. So we remove all the feature extraction layers from machine learning to get to a deep learning phase. Now, do you have any questions out there? Yeah, one thing that I was wondering about is it will be kind of difficult for me to switch to Hindi because these are the kind of topics where uh, I think I'll be able to do a better job if I try to continue the things in English. So after getting a broad view or kind of a basic understanding of, I'll come to that question at the very end. Uh, so after understanding the basic after understanding what the definitions of machine learning, AI, and deep learning is, we're gonna move forward to what all the different types of machine learning systems and how can we broadly classify the algorithms out there so that we can see what all things machine learning offers to us. So one sort of algorithms that you can see in this picture are the supervised learning algorithms. And by supervised learning algorithms, it involves the input data as well as what label the input data belongs to. So if you all have been listening to me very carefully, at the beginning I have explained an example named the Boston housing data set, where you need to kind of predict uh, the cost of the house given uh, how much land in how much land is there in square feet and what area it belongs to. So if you have that data along with what exact price of that house is, you can learn a model so that given this input, you're gonna have a particular label that it needs to predict. So it's a kind of supervised learning problem where given an input, given a label, you're gonna have to learn what all semantics the input has to go through so that we can predict the output. So that's the supervised learning set of machine learning. Uh, what unsupervised machine learning will do, it will not have the label out there, but we kind of ask it to do not the prediction task out there. We're going to ask the unsupervised learning algorithms uh, to do some sort of to do tasks that's going to help in the supervised learning side. The examples will be there in next few sections of the slide, so stay tuned with that. The next very fascinating set of algorithms are the reinforcement learning algorithms. Number one, I like these algorithms a lot. Uh, what these algorithms involve is that they try to learn the semantics of whatever things or whatever problem you are trying to solve. They try to solve that particular problem from experience, and by experience I mean let me explain this with the help of an example. There's a young kid of age 5 to 6 years. You're gonna have to uh, make that kid aware of what all different fruits there are. So what you're gonna do is you're gonna take an apple and then show that apple to that kid and say, hey, this is the apple. And then you're gonna take let's say grapes, and then you're gonna show the same grapes to the kid, and then you're gonna uh, tell him, hey, these are the grapes. And the next time you're gonna uh, ask what the fruit in what are the fruit that you carry. If the toddler says the wrong thing, you're gonna give it a reward. And by taking a reward, let's say a candy, if the toddler tells the right fruit, whatever you carry, you give that a candy. And if the toddler does not tell the right thing, you kind of you do not give the candy. That's the kind of very crude statement. But the broad idea is, if you do good things, I'm gonna uh, award you better, and if you do bad things, I'm gonna reward you, or I'm gonna penalize you in a bad way. So that's the entire thing in reinforcement learning algorithms. So from these slides onwards, I'll be showing a few examples of algorithms used in supervised learning section, where you have the input and a label. The first set of algorithms and the broadly used set of algorithms are named linear regression. And what linear regression says is that whatever label or whatever target you are going to predict from the data, just fit a line to it. And by line, I mean what would be uh, the best uh, p- what would be the best possible mean output that I get given this input. So you can see this is a kind of averaged out curve over here that's gonna help us predict whatever is there on the y-axis, or y-axis I mean the target, and what we feed into the model is the input. So that's the very crude way of defining the linear regression. By mathematics, I just want to explain what it means mathematically, which we do try to avoid, and then one easy explanation. What linear regression means is that it's gonna bring out a relationship between the independent variable. So independent variable will be x in this case, and the dependent variable will be y. So if you all have kind of paid attention in your high school mathematics, so you always write y is equal to f of x. So what the linear regression do is it's going to try to estimate what f is. So that's the kind of mathematical definition of what linear regression is. Uh, and what the best line and what's the easiest way out is, hey, it's going to help to predict the pattern in the data, or the average pattern the data resembles the most to. But you're going to have to but this slide, what I try to explain is that you have to look at your data before you try to even apply any linear regression method. So linear regression by mean you can try to fit a straight line, you can even try to plot, or you can even try to fit a polynomial equation over here to this data. So before you see the data, it is not always recommended to just apply any linear to apply linear regression with any degree of polynomial over here. So this linear line would be 1 degree polynomial, and then if you observe, this is a kind of the data belongs to more of a parabolic trend. So what would be much more helpful if we can fit a polynomial equation with degree 2? That's the kind of entire idea. So does that mean is it so easy? I just look at the data, I can decide the degree of polynomial of that data, so that given any input, just run through the function. Yeah, is the graph here wrong? So uh, no, the graph here is not wrong, but whatever you are trying to apply, or how you are going to make use of the information, is not that much meaningful over here. You are trying to fit a linear line, but the data over here follows a parabolic trend over here. So you're gonna obviously have to look into the data, or what your data actually demands, before you apply uh, the linear regression. So yeah, it's not that easy, because you have to look into the data, or you have to look into the data, and uh, then think of what sort of degree of polynomial out there you want to fit for that xy pair. By x I mean input, and y I mean target. And this slide basically, it just observe this slide very carefully. We do not have to apply linear regression always, because of the fact that if you see the trend over here, the bride is about to get married. She goes to a bakery out there, and then uh, she goes to a bakery out there to get a cake. Yesterday, the number of husbands for her is 0, and today she got married, so the number of husbands is 1. So the bakery owner says, tomorrow the number of husbands for you will be 2, because it's just a straight line, and day after tomorrow the number of husbands would be 3. So fitting a linear regression line over here would be not a good idea now. So you're going to have to look into the data, look into the constraints, before you're going to think of whether or not to apply linear regression, or what degree of polynomial do I need to apply, if at all it makes sense for me to applying linear regression over here. So if this makes sense, we are about to hit the 40-minute mark soon. So yeah, happy understanding. Yeah, this was literally good. So next up, the classification task. So we are still continuing the series where I'm kind of demonstrating what all algorithms out there are for the supervised learning framework of the machine learning. So next up from the linear regression, I wanted to explain is the classification algorithms. By classification, I mean there are different, excuse me, there are different categories out there. Yeah, just to answer that question, linear regression is not necessary everywhere. Yeah, exactly. First of all, you need to understand why you are trying to apply, where you are trying to apply the linear regression, and how you're going to make use of the information after you have fit the linear regression. Because just 2 slides back, I have shown you applying linear regression would be a devastating idea. So you're going to first ask the question how you're going to make use of the linear regression fit, or the model that maps the input to output. And then if that makes sense, you can apply linear regression, otherwise not. So returning back, classification means we need to classify what all clusters or what are uh, categories the data belong to. And just to say, this man is trying to see at a butterfly out there, and he say, "Is this a pigeon?" No, it's not a pigeon; it's a butterfly. So there are discrete sort of outputs in the target, and that's where we apply the classification for. We classify the data into uh, different categories out there. So how are you going to classify this thing? Given a statement, you're going to have to answer true or false. And what sort of guess you want to make by looking at this figure? Like, is this true or is this false? So you should also be very considerate about what you are trying to input to your machine learning model. So True, I like that term. So you have to be very much you need to very much you need to be very much careful about what you are trying to input to your machine learning model, because otherwise the input can be garbage, which would lead to the fact that the model would be garbage. If input is garbage, how you can make the output better? So that's the kind of idea. So moving forward, we have just finished up uh, the kind of majorly used algorithms out there for regression, that's linear regression and classification. For a classification out there, there's a algorithm named logistic regression that makes use of some sort of probability theory. And if you are feeling more excited, you can check out the maths involved in any good article on Medium or the free code camp articles. So before this slide, I just wrapped up what the algorithms in supervised learning involve. Now I want to explain what unsupervised learning algorithms are, and with the help of an example. So one problem statement that I want to show you is that let's say I just I got a whole lot of balls of different colors, and what I did was uh, I have put all the balls over there in a pool. Now I ask you, hey, you need to cluster out the balls and then make a boundary so that the balls do not mix, because otherwise the ball gets mixed. You need to repeat the entire thing again. So I got this very interesting viewpoint that ML can be devastating sometimes. Yeah, exactly. If you are not very careful enough to what input you are applying the machine learning, or what are the assumptions that the algorithm you are trying to use, what assumption it makes use of, and if you're not following that assumption, the results can be devastating as well. So that's the thing. Returning back, the clustering algorithm out there helps you cluster out the various inputs out there, uh, and then you can make use of these cluster data. Yeah, we are segregating the balls out there. So that's the entire idea. If I had just put the entirely mixed random balls over there in a pool, it would be better if you're going to make mm, a, the better use of balls. Just put all the balls of similar color in a bag, and then you're going to make use of. Then you can decide however you're going to make use of that bag. So or one better example over here would be, let's say I have given you the friendship connection graph of the entire entire Facebook backend. So by Facebook backend, I mean you have the information available to you, how all friends are connected in the entire globe. You can with this sort of algorithms, clustering and k-means algorithms, you can try to find out people with same characteristics out there. Because let's say me and my friend Anubhav out there, we like to watch, let's say there is a serial named Big Boss, so I really like watching that show. So by these clustering and k-means algorithms, we can find out what all clusters are there that people get usually involved in, and then you can further make use of if you want to recommend ads to those persons. So that's a kind of very very crude example. Yeah, exactly. The color balls are a kind of very abstract example. So moving forward, what are neural networks? So I've kind of not given a whole lot of examples for unsupervised learning sort of framework. You can look up on the internet out there what different algorithms involve. But I also want to spend some time around what neural networks are and how they can be useful. So what neural networks are essentially, uh, so if you all remember your high school science, there are neurons in the brain, and all the neurons connect together so that the brain can properly function. A single neuron in the neural network is sort of representative of learning the one small signal that whole sort of inputs or the whole sort of inputs can affect the output, or the neuron is trying to learn that relationship, how those inputs is affecting that particular target in a certain way. And if you combine a whole bunch of neurons out together, you'll be able to represent a very complex relationship that explains how these bunch of inputs map to an output. That's the kind of entire thing. A single neuron is kind of representative of gaining one small signal, how the input is affecting the output. And when you club a whole bunch of neurons, uh, it will be a representative of how exactly is the input affecting the output, and you can predict output from inputs. Coming to the question over there, does ML always work on probability as all the inputs can be of the same time? Yeah, exactly. It's always better to treat whatever output you get from the machine learning model from the probabilistic point of view. Your machine learning model should be able to give very low probability on the output, if at all the input data is garbage. If the input data, let's see an example, if the input data over here is garbage, instead of outputting a very healthy number 0.5, that would mean the probability of if it's true or false, what your machine learning model would do is going to kind of raise an exception over here, like what exactly you are trying to ask me to do. So that's the thing over here. That's a very interesting
So
question.
at the end, just show them your blog and show them what machine learning really looks like.
It's all
We
involved
don't want to
maths.
scare you, at least, so at least we can show you something
Okay,
in
we are
reality,
about
right?
my slides are about to end. So
Yep.
uh, if you ask mathematically what neural networks mean, it's a kind of taking one vector. And by vector, I mean, so vector has two components that's associated to it, right? One is the magnitude and one the direction. So neural networks are basically matrices that are applied to that vector. And what matrices can help us achieve, it's going to transform the vectors in some complex space so that we get the output. By transformation, the transformation can be of I guess two types. You can either scale the vector. By scaling the vector means you can stretch it, and then you can either stretch it in the reverse direction, and you can shift the vector. So neural networks are essentially doing stretching and squishing of the input to get to the output in a very complex way. So there are a whole bunch of neurons out there that are doing similar things, stretching, squishing, and as a result of superposition of those neurons, we get to the output. So how the inputs are getting mapped to the output, each neuron is kind of independently learning that behavior by stretching and squishing the input, and the results are clubbed together uh, because they are vectors, and then in this way we get the output. So just a kind of small activity before we wrap up. Uh, so neural networks. So the problem statement here is: imagine you all are neural networks at your home, and what property neural networks have is that they're gonna start they're gonna start the solutions at random. So given any input, whatever the answer you get is completely random at first, and then neural networks look how much away I am from the right answer. Let's say I'm about to predict the price of a house by looking at how much land the house is built onto. First, it's going to predict the random stuff. So let's say uh, the area of the house is 100 square meters. It's going to say, hey, the price is about $1 million. That's completely random, and that's is not true. So what it will do is it's going to look at how much far I am from the right answer, and let's assume for that 100-meter square land or 100 square feet land, the correct price of that is $1,000. So it's going to compute the delta between $1 million and then $1,000, and it's going to update all the neurons inside the neural network with this information. Hey, if the delta is big, you need to uh, try to minimize that delta as close as possible so that you get to the exact output. The next time, if you feed the same 100 square meters to your neural network, this time it can say, hey, it's $1,500. Now we are getting much more closer to the exact price of $1,000. So the broad idea is you're going to start out at random, and then you're going to try to learn what all semantics it involves to get to the output, and then you try to minimize the delta how much you are closer to your output. I hope you were able to understand the example. Uh, Now I'm going to
Yep.
ask you in the comment section out there. Imagine you do not know what exactly the symbol means. So, just I want to explain this problem statement out there, and then I can answer that question. Uh, so imagine you as a neural network at your home. I give you two inputs. You're gonna have to find out how do they relate to get the output, and then you do not know uh, and you also do not know what exactly this symbol means. You are kind of alien to this planet. All right. So that's the problem statement you have, and I want you to help me answer these three questions. uh, and to answer that question, how the neural networks bring us close to the right answer. So what first neural networks do, it's they're going to start at random. Whatever input you give, they're going to output any random stuff out there. What we observe is we compute the difference between what's the right answer to that output and what the neural network has uh, given us as an output. So we compute the difference between the two. In our example, it was the difference of $1 million and $1,000. After we compute the delta, we make all the neurons inside the networks over there aware that, hey, the delta is quite big. You need to minimize the delta out there so that the neural network can serve as a good representative of when you see uh, any area in the land, you can uh, predict the price of that land in a good way, not too far away. So you try to get as close as to the right answer starting from random stuff. I hope that answered your question.
So Vaibhav is asking like, why can't the machine learning or the neural network just set the price to be $1,000? So
Yeah, why
what
it
is
cannot
the
set?
need to change? Why? What is the need of delta here?
Yeah, the broad idea in neural networks is here you need to learn the semantics over there, uh, of how you reached $1,000 from whatever input you give. And it's not that I'm going to always input 100 square meters every time, because if I'm about to fix $1,000 over there in the output of neural networks, then let's say I input to the network out there the land of uh, let's say 1 million square meters. So if the land is big, what semantic we know is that the price going to also go up. So if you're going to fix the output of $1,000 over there, the network just learns nothing. It's a kind of if else condition. So if the input is 100 square meters, the output is 1,000. Else, I don't know. Else it can be random. So you need to operate on the deltas out there so that it generalizes on multiple inputs. So it's not that you need to get the right answer on one input. You need to get the right answer at multiple inputs, and you need to minimize that. Uh, you need to minimize uh, uh, the collective delta out there. By collective delta, I mean what's the difference or how much far away I am in the prediction of input one, how much far I am from the in how much far I am when I predict the output of input two. So I'm kind of minimizing multiple deltas over here. By minimizing multiple deltas, I kind of make a good system that learns how the inputs map to the outputs. So it's kind of all the linear transformation that go into it. Yeah, if you give enough inputs to answer your question, Weber, it's kind of learning the relationship, how the square meters or how the inputs relate to the price. Yes, it's exactly learning
We can
those
also show
semantics.
you some example of like machine learning doing actual work. I'll just share my screen and show you something like how we are
Yeah,
just it machine learning is like a car. We can say like a self-driving car that needs direction. Like you are just steering it once and it goes to a good amount of distance, and when it goes off track, you just need to steer it back to the right track. So that's something like what Sam is talking about. Yep.
yeah. Just to give you an example, how the neural network is going to predict. First, it's gonna 10 and 20. You give these two things as the input. It's gonna go random. Hey, it's 90. But what we know on Earth is that 10 plus 20 is 30. So we compute the difference. Hey, if you are 60 units away from your answer, so you need to minimize that difference and then get as close as to 30. So the next time you input 10 and 20 out there in the neural network, it is getting close to 30, and this time let's say it inputs 25. In the first step the delta was 60, in the second step the delta was 5, and now we can see we are getting much more closer to the right answer. And when I, let's say, input 10 and 20, after trying after making the neural network to learn the semantic, and after trying out a bunch of times, it outputs 30. Then and I say, hey, that's the exact answer. And now the neural network has exactly learned uh, what exactly we are trying to do with these numbers. We are just trying to add them. So that's the entire thing. If you give the neural network a whole bunch of representation power, and if you give the neural network a whole lot of healthy data, it's going to learn what all semantics it involved from mapping the input to the output. That's a kind of crude way of defining things. All right, so let's take a few questions out there. So if we are alien, yeah, uh, yeah, that's a good question. If I'm saying you are the neural network in your home, and then we are trying to correct the new neural network. I'm sorry if I have skipped that. I'm also observing the new neural network. If it's trying to not do the right thing, I'm gonna penalize the neural network with how much it is far away. So it's going to start at random. I'm going to penalize the network by 60 units in first step, and then after I input the second thing out there, I'm going to penalize the network by 5 units, and then if I input 10 and 20 again, it's going to learn the right semantics. So there is a supervision over here that is required so that the neural network learns the correct thing. There is input, there is output. We learn the mapping to minimize the delta. So it's a kind of supervised learning task that I also explained some slides back. Yeah, we are telling the right answer to machine as well.
So there's one more
Uh,
doubt, like while learning ML, so where you can practice, like where should implement the things?
yeah, you can first try out a bunch of different standard data sets out there, what those data sets actually involve, and how you can make use of those data sets to actually predict or actually learn something meaningful. So from those standard data sets out there, you can try to learn the machine learning algorithms out there that can help you make meaningful sense out of that data.
Yep.
Uh, where should I implement them from practice? You can, if you are willing to practice them in Python language, just fire up Jupyter Notebook session and practice the algorithms over there. Get a pen and a notebook if you are also interested in learning more about the maths that they involve. So here explicitly in this session, since time is short, I have not very much gone into any and all maths that may be required for any algorithm like linear regression or clustering and k-means algorithm out there. But I try to
Yep.
give one uh, essential idea, like in this example, how the neural network works. They minimize the deltas. So I hope you get the idea, and if you are interested to check out the maths, there are whole bunch of resources out there. Uh, Whole bunch of resources out there that can help you understand the algorithm very good. One resource that I recommend that I also watch in free time is the StatQuest YouTube channel over there. It's kind of they kind of very intuitively explains what any algorithm is trying to do, and then they're going to explain what math it involves. So I definitely recommend to anyone the
Yep.
StatQuest channel to answer. So now we can take some questions out there, but I do have a few memes that I want to show. But yeah, let's take the questions first. They are much more important.
Yep.
How have how we have to start a machine learning journey? Like it's exactly up to you. Uh, One thing I was majorly excuse me. So one thing I was majorly interested into when I heard the term machine learning is that there was some sort of the very complex term that seemed to me was neural networks that can learn any and all the relationships out there, and that got me motivated enough. Hey, uh, this seems interesting. Why not check uh, this thing out? And when I started looking into the way neural networks work, it was all maths and all metric multiplications out there. And I said, hey, it's not that difficult. Let's learn a whole bunch of other algorithms out there so that I can get a better sense of to what all places machine learning can be applied. So you can be motivated by literally anything, like the way YouTube recommendation works, or let's say if you have heard of the DeepMind company, they are trying to they're literally trying to make
Yep.
bots that can play games. So that can get you excited. Hey, how we can create good agents or good bots that can play
Yep.
games, and even I then I can test out how good I am in that game against my created bot. So
Yep.
yeah,
Let's
then you
check
need to
out like.
find. Yeah, go ahead, Anmol.
Yep. Let's check out an example. Like, can you stop sharing your screen? Let me share something.
Yeah, let's see.
So just a minute. Let me put this away. Let me put this away. This here. Just a minute. So I think my screen is visible. Yep. Right. So this is kind of a cool tool. So let me sign in. So let's make a artificial. Let's use artificial intelligence to write a article maybe. So thank you, Sayam.
Nice.
So let's see how we are driving a car. Like we are just supervising the machine learning. We are giving it some examples. We are giving it a direction to move, but it's moving for us, right? Thank you, Sayam, for uh, AI session.
There's one interesting comment over there. Uh,
Yep. So
uh,
let's try.
that we
So
are trying to learn machine right answer like a child. So I guess what your question means is,
we
are
are
we trying to
training the
make
machine. Yep.
training the machine learning model like a child? Yes, it's kind of exactly like that. First, it knows nothing. It tries a whole bunch of things at random, and
Yep.
then we make the
So
child aware, hey, to do the right
yep.
things by minimizing your errors. So that's the kind of thing.
So this is something like we are training the machine. We are giving feedback to the child. So we gave this as input. Thank you, Sam, for the AI session, and it gave us these headlines like these outputs. So we'll reward it by selecting one. So which one becomes your favorite? So uh,
Uh,
thank you, Sam, for the fantastic AI session. Right. So like we can edit it, but I think it's good to go. Let's
we're
generate an
gonna
introduction
tip
to our session.
$1 to them.
Yep. So it's machine learning is running and machine learning is relatively slow. Like you can't just predict something. So it took this particular string and generated these things. So let's
Oh
select a
wow.
particular thing that is good, that looks good to us. So Sam is AI app. No, Sam is not an app, right?
No.
We should go to step two. Sam is not an app. I was amazed and felt talking to a real person. Thought of a funny joke. He was able to keep me even laughed.
Let's see if I can
Uh,
zoom into whatever screen you are presenting. Yeah, there you go.
let's go to the single. Hello. Yep. So am I audible?
AI is a hot topic these days. Yes,
Yep.
exactly. But it's
Yep.
it's
Let's
not that
let's take
hot.
it. Yep. So AI is a hot topic and a hot
It's
topic
just
debated
math.
by cool folks.
Exactly like that.
Yep. So this is all things. Let's generate outlines. So we are
Oh,
just driving a car. We are steering it to a right direction. So these are the bullet points for our article. So what is AI? The evolution of AI. The future of AI chatbots. What is AI?
so from what I all gathered, you
I
you
think we
you had,
need AI to make a selection also.
yeah. There are so many good outputs out there. We need to find out,
Yep.
hey, what can be a what should be the best amongst them.
Let's have a small one. So this. Yep. So what is AI? Evolution of AI. Section three. Uh, I am the AI
Engineer,
research.
researcher.
Yep. Come on. Just a minute.
Oh,
There's
write an article.
our session with Sam. So I think I'll be out of credits. Ouch.
Oh,
Sorry.
so the broad idea I see is that you are trying
So
to create a
yep,
big article out there with giving as less inputs as possible, but
yep,
still trying to uh, get the best article out there with just a few words.
yep. So we just gave the child the neural network, like just tell us what is 10 plus 20, right? So he gave us particular outputs. We just took one as the favorite, one that has the least delta to our expectations. So
Yeah,
this was the least delta, right? So we took that, we again fed that as an input, and we got more text, and this way we can generate more text and submit it as our assignments, right?
yeah, exactly.
So
uh,
it was quite cool. So AI can do a lot of things. Like there are around 45, 50 features that we can generate. So we are also generating our YouTube titles and stuff from this. Uh, we can write emails, everything. So AI is going to
yeah.
be new things. So that's how AI works. That's how.
Do we have any more questions out there? Because
Yep.
how can I see the
So
comments?
So the model that was used at this writesonic.com, this is by the way writesonic.com. This is a it's a cool app. So they must have used something to train their models to give us some input, right? Because it can't be directly random. So if I said like thanks to Sayam for AI session, so it should have given me something related to AI, else it should not be like doing a baby shark session with us, right? So there is something involved in training, and it is also getting trained in situ with like taking our responses and giving us new outputs. So that's great. Yep.
Yeah. And then this is the YouTube channel is starts with Josh Temer. Yes, yeah, it's exactly that.
Yeah.
Does this information given to the system earlier? Yeah, I guess the example that Anubhav explained, the network was already trained on a whole bunch of different similar patterns that it needs to output. So
So I don't particularly use Copilot, but how was that info from input? No, it wasn't from internet. It is not fetching internet things, but it is sitting on bunch of a huge data set, and it's generating out of its own data set, right? So it is the biggest, probably the biggest models in the machine learning domain. So there is
yeah,
one thing called GitHub Copilot. So it runs on OpenAI by Microsoft. So I do not have its subscription. Like I do not use OpenAI. But what you can do is you just write a comment in your text editor, and it will write the whole code for you. So it's like AI, just like we are writing articles. It's like it will write the whole functioning code for you automatically. So probably we are also going to get out of our jobs to the AI. Yep.
no, it's not like that. If you are kind of deploying any machine learning agent, you need some sort of supervision over there so that it does not go wrong. Or number one,
Yeah.
and the other thing is, as soon as you see more data, or as soon as you want to improve upon whatever model you have deployed, obviously anyone is not getting fired from the jobs. We
Yep.
need people out there so that the models can be proved itself. So
Yep.
that's the thing. Just one last thing before we wrap up. The slides that I've shown you, uh, they have not been prepared by me. They have been, I have taken all these memes online. They have been prepared by Harsh Aryan. Uh, if I can share you the slides, all his Twitter handle as well, I have mentioned at the end. So
Yeah.
I just need to mention where I've taken the slides and all these memes from. So
So I
uh,
don't think machine learning is reducing number of tech jobs, but machine learning is boosting tech jobs a lot of manifold. So all the startups, be it Right Sonic, be it other startups, they are generating a unique product idea, a unique selling point using machine learning, and they need engineers to sustain their development, right? So
yeah,
machine learning is kind of bringing a new boom to the culture and the technological the technological economy. So machine learning is creating jobs instead of reducing it, but for the
exactly.
right skill. So you need to be skilled in the right way to get adapted by machine learning. Yep.
Yeah, one thing I have also observed is that this era that we are living in right now, it's just the beginning of machine learning. You are
Yep.
just about to see some sort of robots out there and some sort of automation. Just try to imagine how things will look like in, let's say, 2050. And I am kind of having a hard job try to imagine how much better we would be able to make good use of AI and then try to
Yeah.
use
So
to
yep.
improve. So things will be much more better, and then things will be much more better, and we'll have a whole lot of improvements in the field of AI. So
Yep. So also, Sam, can you share your blog and your websites? We can get
yeah,
a
I
grasp
have
of.
not the good thing is I have not
it's
updated
not
my
it's not to scare you, but just check out how machine learning and the maths involved is so complex. That got simplified
uh,
by means of course.
oh, how can I
So
comment over there?
you
There's
can
this private chat.
just share your screen once, like show
Yeah, I
what
can share
you
screen.
who you are.
Who you are? I'm a person living on the planet, surviving and enjoying with memes. So this
So
is a
this
kind of
is
my very old website which I have not updated, and I felt ashamed saying this fact. I have not updated it since 23rd December in 2020, so it's about more than 1 year. So what all stuff it involves? It's the most thing, uh,
Yeah.
or the good thing that I'm very proud of is that I had this algorithm named variation inference explained in depth in this blog. So with intuition, with examples, with plots, with mathematics involved, it's just one complete blog that can help you answer any and all questions if you have in this topic. Uh, and if you
Yeah.
dig deeper in it, it's a whole lot of stuff
Yeah.
out there.
Check that out. It's like
So
it's something like I'm alien to that
Django,
mathematics.
I don't know. It's about 2 years when I had stopped using Django, but the time I had used Django, it was fun building backend
Yep.
applications. So
Fast
oof,
API being used.
yeah,
Yep.
open
So,
source is crazy. Even the fast API and all sort of good libraries out there that develop at such a rapid pace out there in open source. So that's a good thing that we can learn
do come up,
building out
folks.
things in open.
We think
For
that
sure.
one of you can, at least one of you can become a good AI engineer and support, and probably you can take out your AI skills and raise a new startup. So also, a reminder for registration at Hackmole. So we have Hackmole 3.0 and registrations are open. You can make teams with your friends from your college or other colleges, and you can collaborate and win. So we have a lot of cool swags and stuff that is in pipeline. So it will be really great for you to participate in Hackmole and learn more, right? So Hackmole is up, and you can also register and you can get swags, and there are particular domains you can make build stuff on. So if you're doing something on blockchain, we have different cash prizes. We have different cash prizes for junior track and senior track also, right? So do come up and participate. Thank you for the session, Sayam. Yep.
Oh, I have a quick question. How are you going to ship the swags?
So we do have some funds, and we'll be shipping the swags like once the
Yay!
hackathon is over.
Nice.
Probably
All
we'll
right.
also ship you a T-shirt for gratitude, like for giving the stuff. Yep.
Nice.
And
Nice.
I'll personally
I
deliver
like
that. I'll
I
personally
like that
deliver
idea.
it.
So
Yep.
Anubhav and I live about 5 minutes away from each other.
Yep.
So thanks
Thank
for
you,
this
folks. Thanks
knowledge
for
session.
joining. Like, yep. We are just ending
Yeah,
the broadcast. Take care, folks. Bye.
it it was a wonderful session, everyone.